But as we go through this, and again, you are in one of two situations. Either you did the work and you're getting feedback for the hard work that you did, or you didn't do the work. And if you're a friend that has a blank piece of paper, please do not frantically copy down my work or my answers, because you learn nothing from copying. You have the key, it's yours to keep. It's not one that you have to return, it's on the back of your warm-up. So as we're going through talking about it today, if you did no work, my ask of you is to follow along on the key. Save your paper for when you want to go back on your own time and practice these skills, and then you can check your work with the key. So no one's pencil right now is going crazy copying down my work. Either you did it and you're checking your work, or your blank piece of paper is tucked underneath and you're listening as we talk about it. And you can take notes on the key. Maybe you want to highlight, circle, star something that you didn't know how to do, but you're not doing the work right now, because then you're missing the conversations that we're going to have. Are we clear on that? Before we jump into this, would you please turn to your new partner? Would you say hello to them? Not yet. Would you make sure you know their name and they know your name, including pronunciation, so make sure you say it loud enough so they can hear it. And then I want you to talk about one thing you did over the weekend, and you're not allowed to use the word sleep or slept or any version of your being horizontal with your head on the pillow in your bed. Turn to your partner and say good morning. Go. What I'd like you to do, take a look at this first section. We're going to go through this section by section. And I want to point out a couple things on both the key and with these types of problems. When you're talking about proportions, our cross products is going to be our first strategy. Cross products is just a shortcut of the multiplication property of equality. So when I'm multiplying 7x and 12 times 5, that's really just a shortcut to multiplying each side by 7 and then multiplying each side by 12 to have that cancel out. So you can see if I were to work on this, my 7s cancel out. Here my 12s cancel out. And that's how I get 7x is equal to 60. So you can see those cross products. No C's. Those cross products are justified by the multiplication property of equality. Some things to make sure that you remember is that anytime that there's an expression, you have to bubble wrap that. So that's going to be 5 times this quantity, and you have to make sure that you then distribute that 5 to both terms inside. If you wind up with x times x, I still have people calling this 2x. Make sure you know that x plus x is equal to 2x. X times x is equal to x squared. So we have to make sure that we recognize that x times x is x squared. I still have some people messing that up. Any questions on any of those proportions, 1 through 6, you want to talk about? All right. Now when we complete these ratios, we can explore our different properties. And what's interesting is I had a student one time who loved problems like this because she would just flip-flop the x and the 10 to always keep her x up in the numerator. So when she would write this conversation, she would flip this, so it was 4 over 10 is equal to x over 15. She liked having her x in the numerator. That doesn't matter when I go to do cross products, when I go to solve, but it's interesting to look at the different proportions that I can solve. So if I'm looking at this being my true standard, 4 over 5 is equal to x over y, then I need to make sure that no matter what, I'm multiplying x and 5. No matter what, I'm multiplying x and 5. When I'm looking here, no matter what, I'm multiplying x and 5. So between the reciprocal property and exchanging my means and extremes, I can justify each and every one of those because I always end up with 5x is equal to 4y when I'm solving. Working with radicals. When we're talking about simplifying radicals, we've been doing that for a long time, so check your work with mine. The properties of multiplying radicals, if our indexes match, and your index is this thing here that's telling you, and that's one of those invisible things in mathematics. If there's nothing tucked into this square root, then you know it's a square root. Anything more than that, you'll see a 3 or a 4 or a 5, and that's how many of those identical factors you need. If our square roots match, the properties of multiplying radicals tell you your coefficients are going to be outside, and whatever is under the radical sign can go in there together. So the square root of 6 times the square root of 3 is going to be the square root of 18. So when I look at this is 10 times the square root of 16. This is going to be 9 times the square root of 12. My commutative property of multiplication lets me regroup and put my coefficients out front and the numbers under the radical inside. Then of course you have to simplify. So obviously the square root of 16 simplifies, but here's going to be a perfect square. You're going to be able to pull a 3 out of this one and a factor of 4. Take the square root of 4 for that one. Any questions on simplifying radicals or multiplying radicals? Okay. When we have an addition sign like this, all you have to do is your order of operations. This radical sign works as a grouping symbol. So what you do is you have to do what's inside there first. So 36 plus 64 is 100. So that's going to be the square root of 100, which is 10. Lots of kids want to take the square root of 36 because they're like, oh, I see a perfect square. Or 64, oh, I see a perfect square. Nuh-uh. You have to do that grouping and add them first. So this is going to be the square root of 32. And then this is a multiplication problem, very different. So take a look at the key and make sure you can simplify these as necessary. We've talked about the trick for threes. 1 plus 4 is 5. 5 plus 7 is 12. 3 goes into 12, so I know 147 is divisible by 3. You know that trick for threes, right? And the reason that that matters to me is I can rewrite this as a fraction and then simplify that fraction. 3 goes into 14. Help me with my math. That's 49 times. That simplifies to 7. Did I get that right? So if you can simplify that fraction first, that'll help you get your radical out of the denominator. If your radical is in the denominator and you can simplify, it's not a problem. This one simplifies to 3. The square root of 9 is 3. 9 divided by 3 is 3. When I have a radical in the denominator, I'm not allowed to. So instead of simplifying that radical, if I want to, I can just rationalize it first and simplify later. And I forget what I did on the key, whether I simplified it first or not. But this is going to give me 5 times the square root of 20 over 20. This simplifies into 1/4. When I go to take the square root of 20, it has a factor of 4 in it, so that becomes 2 roots of 5 over 4. And then, of course, these simplify to the square root of 5 over 2. So being able to manipulate and simplify those values is something that should come naturally to you. If it doesn't yet, you need to continue working on it, because in mathematics, this is the kind of number we want to work with. The simpler, the better. Questions on the first page? Would you please turn to your partner and would you please share with them which problem you thought was the hardest on the front page and which problem you thought was the easiest? Turn and talk to each other. Go. On the back of this worksheet, you have some more simplifying ratios. You're going to get your quizzes back in a minute. And And this is something that really isn't even part of our unit. This is 5th, 6th, and 7th grade math. And some of you lost more points on this than you did on the rest of the quiz. So we need to make sure that you're understanding how we simplify. It surprised me that not all of you know your conversion factors, like how many feet are in a yard or inches in a foot and minutes in an hour. So a lot of that stuff should be at the front of your brain. As an intelligent human being and future productive member of society, you should know how many inches are in a foot. So ratios 1 and 2 are just fractions that you're simplifying. All that you're doing is finding a common factor. I know that 48 and 60 are both divisible by 12. So the interesting thing that we do with these values is if I want to divide by 12 and divide by 12, that's actually what I'm doing as I simplify this. 48 divided by 12 is 4, 60 divided by 12 is 5. So this process of simplifying by pulling out that common factor, that is what I'm doing. I'm finding values of 1 that I can pull out. Maybe you didn't know 12 goes into 48 and 60, so you started off with 2. Maybe you ended up with 24 30ths, and you're like, oh, I can take out another 2. And then you ended up with 12 15ths, and you're like, oh, I can take out a 3. And then you got your way to 4 5ths. If you can't do this math in your head and you're calculator dependent, that will get you the right answer today. And you're allowed to have a calculator in this class, no problem. But it's going to jam you up in a couple years. Because if you're on the path to take calculus, AB calculus, or BC calculus, within the next 4 years as you travel up, it's going to work against you because, hold on a minute. I'm going to sign. All right. When you have your calculator, oops, not what I wanted to do. Try again. Now, here we go. Anyway, to continue what I'm saying, if you end up in calculus, which is the route you're on, geometry honors goes to algebra 2 honors goes to pre-calculus honors or regular, pre-calc regular and pre-calc honors as 11th graders. You guys end up in AB or BC Calc your senior year, and half of the tests in both pre-calc and calculus are no calculator. So if you are calculator dependent to do something like 48 60ths, you're making it so that when you get to those classes, pre-calc and calculus, you're going to be handicapped. It's going to be too hard, and it won't be because the calculus is too hard for you. It's because the 5th grade math is too hard for you because you never invested the time and energy into learning your math facts. So the good news is start now. The good news is that you can start lifting weights at any time. The more energy and effort you put into learning math, the smarter you will be. So if you come to this calculator and you go 48 divided by 60, and it gives you this decimal, and you go math, frac, enter, and it gives you that decimal, good for you. You use the calculator to do what your brain should be able to do. So if it's about getting the answer correct today, rock on. If it's about learning the math so that you can take those courses and set yourself up for success down the road with math, then it's time to exercise your brain. The more you spin the numbers around in your head, the smarter you get. Every day that you do the math in your head, you get smarter. Nobody gets strong by watching somebody else lift weights. You know what I mean? Any questions on how to simplify any of these 6? With the conversion factors and whatnot. All right. So take a look at 7, 8, and 9. If we're finding the ratio of girls to boys, in each class, I'm asking you for a part to part ratio. So if I have 15 boys and 28 students, you know that the girls to boys is 13 to 15. You know you can do that math and subtract to get the number of girls and figure out that 13 to 28. Any questions on those three ratios? All right, here comes the part that everybody loves. If you skipped out on factoring the quadratics, then I beg and implore you to please go back and remind yourself how to factor. We did a whole lesson on it before. There's a individual smart notebook and a video and a folder for it on our Schoology site. You can't get through math without knowing how to factor. Algebra 2 will be a disaster for you. So you have to make a decision to jump in and figure this out. And every single one of these problems starts with this template where you split your x's, because x times x is x squared. What you're looking at here is a quadratic trinomial. Quadratic because x is to the second power. Trinomial because there's three terms. Quadratic trinomials are going to be something that you have to know how to solve. Step 1 in solving them is factoring. So the first thing you're going to do is split your x's, because x times x is x squared. You want to break this down into the two things that are multiplied to get it. I'm looking at 10, and in my head I see 5 and 2. You look at this quadratic trinomial, and you need to be able to see in your head its factors. You look at your first term, that one's easy. You look at your last term, and you're talking about 21. So what you need to do is break down 21 into all of its factors, and you're looking for two that add together to be 10. When the signs are all positive, it's easy. Plus 3 and plus 7. When you have a negative product that comes from one sign being positive and one being positive, so this value here is actually the difference instead of the sum. So if you stick with 7 and 3, I know the 7 has to be positive because that carries the sign. The bigger number carries the sign. So plus 7 minus 3 gives me plus 4. If I have here still 21, if I have a positive sign here, that means that these two signs matched. So a positive product is possible either from positive times positive or negative times negative. Gives me a positive product. This sign here as a negative is what tells me that these two are negative. So when I look here at 20 and 21, I know that this one can't be factored. Do I have prime on the key? Yeah? Yeah, cannot be factored. Because if I put a 1 and a 21 here, the only way to get 21 is 1 and 21 and 3 and 7. But this would have to be a negative 22. So that one cannot be factored. If you get a value that cannot be factored, the word that we use is its prime. The same way we talk about a prime number, like 7. You can only break it down into 1 and 7. We call that number prime. When you're factoring, you want to always look for a greatest common factor that can come out of your expression. These last three are a special pattern called a sum and a difference pattern, where you're going to end up with having squares. Hold on. And you end up with what's called the difference of two perfect squares is going to give you your sum difference pattern. Here's a perfect square, here's a perfect square. And what you end up realizing is your middle term actually ended up zeroing out. So plus 10x and minus 10x gave me 0. So whenever you see the difference of two perfect squares, you know that this middle term zeroed out. You have 0 x's for the middle term. So they're always going to factor into what we call the sum difference pattern. X plus the square root and x minus the square root. This 5 that I factored out first just hangs out as a coefficient. The ones above it are a second pattern called a square double square pattern, and what they end up factoring into is a perfect square trinomial. Now, if you end up writing it either as the same value multiplied by itself twice or using the exponent, they're both good answers. So whether you said it was x plus 5 squared, up to you. So the next part is, okay, why do we factor? We factor because we're going to have to solve quadratic equations. Anytime you have a quadratic equations, the graph of a quadratic looks like my green yarn over here. The graph of a quadratic is called a parabola. And that parabola crosses the x-axis twice. So you think back to your algebra days where you had to find the roots, the zeros, the solutions. Your roots are where this graph crosses the x-axis. You want to find where on this axis does this graph have an output equal to 0. Those are your zeros. What input value gives me an output of 0. If it's a linear equation, it crosses crosses your axis once, and that's what you want. If it's a quadratic equation, it crosses the x-axis twice. When you get to algebra 2, you're going to learn about cubic equations. Each through power of x gives another term. So cubic has 1, 2, 3. Follow the pattern. How many solutions does a quartic have? 4. The quartic equation looks like this, where you have 1, 2, 3, 4 values of x. Each new power of x is another answer you gotta find. We find them by factoring and setting the pieces equal to 0. So when you look at something that looks like this, I'm going to factor it by calling this x plus 7 and x minus 2. My zero product property says, if any of you watched, what is the movie about the 3 black women that work for NASA? Hidden Figures. And you ever see the movie Hidden Figures, where the really smart girl as a kid, they send her to a super smart school where she's in a class with all older kids, and she's this little like 8-year-old in a class with seniors, and she goes up to the board, and I love her explanation of how to solve this. She's like, well, it's obvious. She's this little 8-year-old talking to high school seniors, and she's like, well, it's obvious. If something times something equals 0, then one of those things has to be equal to 0. The only way to get 0 as an answer in a multiplication problem is if one of your things is 0. There's no other way to get an output of 0. So we count on this in mathematics. We put everything to one side of the equation, break this down into its factors, and say, okay, x plus 7 could be equal to 0. X minus 2 could be equal to 0. Which means x has a value of 2 here, x has a value of negative 7. At positive 2 and negative 7 is where your graph crosses the axis. You can see this on your calculator. Join me. Go ahead and put x to the second power plus 5x minus 14. So make sure your partner knows where to type that in. You put it into the function screen. See this y is equal to? That's called the function screen. When you press y is equal to, do you see how all the y's are already down the sides? You don't need to say is equal to anything. That y is equal to is already set up for you. Everyone good with the x squared plus 5x minus 14? Turn to your partner and make them show you that you have it entered in. Check in with your partner. Everybody good? Do you know how to do it? Anybody need help? All right. So your next thing, I don't know what your calculator was on last, so we're going to reset it. Go to Zoom and press number 6. Zoom puts you into a Zoom standard. And there we have a picture of our graph. If we want to see the whole curve, we can zoom out. So go back to Zoom and arrow down to choice 3 and hit enter twice, and then you can see your graph. That's an x squared graph. That's a quadratic graph. That's a parabola. And you can see it crosses the x-axis twice. You found where it crosses it at -7 and 2. If you go to the table of values, if I arrow all the way up to -7, there's my output of 0. If I arrow down to +2, there's my output of 0. So the calculator can give you these answers and justify what we did for your quadratic. Number 23 was an interesting one, because if you look at number 23, 5x squared plus 2x minus 2 is equal to 0. My step 1 is to move everything to one side of the equal sign and set it equal to 0. That's how we solve quadratics. If you see that little squared, move everything to one side of the equation. Now when I go to factor this one, it doesn't factor. So this is one where you end up using your quadratic formula. You know A has a value of 5, B has a value of 2, and C has a value of -2. Your quadratic formula should be memorized. Your x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I doubt any of you have it memorized. I can't get you to memorize the distance formula. That's a fun song that you can sing to Pop Goes the Weasel, the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And I know that last year they didn't make you memorize it because A, they give it to you on the formula sheet for the SOL, and B, you were taught to enter stuff into Desmos with sliders, so you didn't have to do it over and over and over again. So that's why you don't know it. But when you have to solve a quadratic on a test that doesn't give you the formula and doesn't give you a calculator, that's what you need to know. So when we talk to algebra teachers who don't teach kids how to be not calculator dependent, we need to remind them, you're teaching kids that are going to be taking calculus someday, and you're setting them up if they don't know or have this memorized or know that they need to memorize it. When we plug in for x, I get x is equal to the opposite of b, here's my 2, plus or minus, that's that plus or minus, it reminds us that there's 2 answers on either side. The square root of b squared is 4 minus 4 times a times c all over 2 times a. Plugging in those values, that's what we get. My x is equal to -2 plus or minus the square root. 4 times 5 is 20. 20 times -2 is going to be positive 40. So 4 plus 40 sounds like 44 over 10. Because this is not a perfect square, I know that there's no real solutions. So I can simplify that. I know 4 comes out, so I know I have x is equal to -2 plus or minus 2 roots of 11 over 10, and these 2's can cancel out and give me a 5. So x is equal to plus or minus, oops, I forgot the 1, hold on. 1 plus or minus the square root, that should be 11, of 11 over 5. That's what you need to be able to do in your head without a calculator in calculus. And the thing is, the calculus teachers don't have time to teach that to you because they're teaching you calculus. So, that's the quadratic formula. That's how you solve a quadratic that can't be factored. Any questions on the rest of the sheet? So here's the deal. What you do with this sheet, totally up to you. If you never look at it again, then you're choosing to not know how to do this stuff. It's your choice. You have the answer key. If you're going to draw on it or make pictures, or then that's your choice. This is the algebra that you were supposed to walk through my journal. And I can tell by all of your faces that you're like, if I gave you a test on this today, that would not go well, would it? Would it? I'm thinking that Camilla's too busy drawing pictures. All right, here's your quizzes back. Okay, in your warm-up, flip your key over. You have some more of these triangles, and we want to write a proportion to solve for x. If you're struggling with this, you might want to follow Lizzie's lead and pay really good attention in the warm-up because it makes a difference. I know that these two triangles are similar by angle-angle similarity. So I have my green triangle and I have my blue triangle. If I need to pull them out and look at them separately, I can. But what I know for sure is that they have this angle in common and they have this angle in common. So because of angle-angle similarity, I know that these triangles are similar. Are we good on that? All right, so with your partner, what I'd like you to do is I'd like you to discuss, if I wanted to solve for x, what proportion would I write? Talk to each other for 1 and 2, 3 and 4. Write your proportions to solve for that value of x. So you mark it, set, go. All right, let's see how you did. If I want to solve for x, what I have to do is find corresponding sides of these triangles to compare. So when I'm looking for my x, I know right away that it's the long side of this triangle. So whatever proportion you write, remember there's 8 different possibilities for what I'm about to fill in. Let's see if we agree. So I know this side is going to compare to my 45-degree side, or my 45 length side. So I'm going to put x there, and I'm going to say it corresponds to that 45. Now, if you did it different, don't erase yet. There's a chance you're still right. Because now that I'm going big to small, over here I'm going to do big to small. 32 plus 40 is going to be this measure here. This measure is 72. So I'm going to go big, and then my small is going to be this measure here, which is 40. Now, if you're not sure if your proportion was right or not, test the cross products, because you should have been multiplying 40 by x is equal to 45 times 72. And if you, as long as you were multiplying 40 by x, you did it right. So whether you compare corresponding sides of similar triangles, or you compare 2 different sides per one triangle, and this is what I'm talking about. A lot of times kids prefer to say that this relationship between x and 72 has to match this relationship between 45 and 40. So by exchanging these means, I can talk about my 2 different comparisons. Big to small, or just within the blue triangle and just within and just within the green triangle. Either way, no matter what, your cross products are going to be 40 times x. Are you with me on that? All right. When I go down to here, number 2, when I'm asking about solving for x and I'm looking for this variable, I need to, again, think about my triangles. I know that the green and blue triangles are similar because number 1, they share this angle. And do you see how they're parallel? So I know that they're also going to share these corresponding angles. So my triangles are similar by angle. But now let's talk about the different lengths of them. Here I have 15 and here I have 25. Here I have 27 and here I have 25 plus x. So you have to make sure that you're putting the right values in as you go to compare. So if I talk about 15 is corresponding to 27, then I know that 25 is corresponding to 25 plus x. Now again, if you put the opposite ones in, then maybe your means are exchanged, maybe your extremes are exchanged, maybe you did the reciprocal, maybe you did it in a different order. There's 8 different things that you could have written. I want to make sure your cross products match mine. I want to make sure that you are distributing 15 across 25 plus x and having that be the product of 27 and 25. Questions on how to do these? Revisit these last 2 with your partner and make sure that you have them correct. Go. Check your word with mine. How did you do? And you can check it by looking at your cross products. Now, I'm not taking the extra step to solve these because solving proportions, again, 7th grade math. It's the setting them up. That's the geometry that we care about. Now, whether you're comparing x to 10, because these are corresponding sides, big to small, 27 to 15 is big to small. If you reversed your means, you might have said x is to 27 as 10 is to 15. Notice you're still getting the same cross products. Make sure you have 15 times x. Here, where we're talking about x is to 4.6, as x plus 4.3 is to this sum, which is 8. If you switched your means, then your proportion might not look like mine, but make sure that 8 times x is equal to 4.6 times x plus 4.3. You want to make sure that you have that correct. Are we good? Questions on this you want to talk about? All right, take out your buckets. So this is what I talked to you about being that shortcut that you can do for the side splitter theorem, but you can only do it if you are splitting your sides. So these overlapping triangles that are similar because we're sharing an angle or the sides are parallel, all of these angle similarity problems lead us to an interesting shortcut. If a line is parallel to one side of a triangle and it intersects the other 2 sides, then it divides the sides proportionally. So what they're saying here, and we can add some A's and B's and C's and D's into this. What they're saying is instead of having to look at the side of the big triangle being A plus B and writing that proportion, we can now say that these sides are split proportionally. So A to C is equal to B to D. And keep in mind, if you interchange the means, you can talk about A to B is the same as C to D. All right, but I have to warn you, the parallel lines only split the sides, not the bases. So you want to make sure that you star this, circle it, because when you mess it up, you're going to be like, what? How'd I get this one wrong? And I'm going to say to you, go back and look at what you starred and circled in class. The converse of this says, if a triangle divides two sides proportionally, then it's parallel to the other side. So if you have this true story, then you can go ahead and prove that those are parallel. If I have A to B and C to D, if I have this as a situation, then I know that they're parallel. So remember, the word corollary means, oh yeah, while we're here, we might as well mention this. It doesn't have to be triangles. We can have a side splitter theorem if I don't have a triangle. If I just have a series of parallel lines and I'm intersecting two transversals, they're always going to divide those sections proportionally. So if I have my A and B and my C and D, I know that A to C is going to be B to D, because those sets of parallel lines are going to divide any two transversals proportionally. The next conversation that we're going to have is our triangle angle bisector theorem. And we'll prove this in a little bit. But the conversation now says, if you have a ray bisecting an angle, so notice here is your bisected angle. Then it's going to divide the opposite part of the triangle proportionally to the two sides. So if I go ahead and again call this A, B, and C and D, then I can write a proportion where A is to C as B is to D. And again, I can exchange my means. So I'm telling you that if CD is an angle bisector, then it's going to bisect that third side proportionally to the lengths of the other two that create that angle. And this is going to be the one that when you're staring at a problem and you don't know what to do, this is the theorem. This is going to be the one that you forget. This is going to be the one where you're looking at it going, well, wait a minute, I see that's an angle bisector, and you're going to look for this triangle center. You're going to be curious, is it the in-center? You're going to have all kinds of questions, and then I'll say to you, that's the one that I told you you'd forget about. Here it is. So go ahead and put another star on this one, where I say go back and look at your stars. Now it's better to do practice and have these. You did these problems already. And when you did these problems already, I told you that you weren't allowed to say 5 is to 7 as x is to 12. I told you you can't do that. And I made you write out a proportion for a small and a big triangle. I made you say that x is to x plus 5 as, I think I mixed up my colors, 12 was to 12 plus 7. The interesting proportion here, and you can look at this, do you remember that one property of proportions where we had the add ones? Do you see that x over x is 1? Do you see that 12 over 12 is 1? So if I have my sides of my triangle split, instead of dealing with adding to get the bigger sides, I can just say this is 5 is to x as 7 is to 12. And if I solve both of those proportions, I'll get the same value for x. My side splitter theorem gives me that shortcut. If your sides of your triangle are split, that's what you're allowed to write instead. Now the warning is, for something like this, that's not my sides that are split. I have one side split and I have a base. So I can't use the shortcuts. I can't use 11 and x as my sides because it's not the side split. I have to deal with this whole side being x plus 11. So the proportion that I write has to be 20 is to x plus 11 is equal to 9 to 11. I'm not allowed to use the shortcut for that one. With your partner, take a look at the next two. One can be written using a shortcut and one can't. Decide which is which and write your proportions. Go. All right, let's check it out and see how you did. Can I write this first one using the shortcut? Yes or no? Yes, because it's my sides that are split. So I can go ahead and say 13 is to 11 as x is to 9. And if you reverse your means, that's okay too. You could have written 13 is to x as 11 is to 9. However you want to set it up, you'll be sure to get the right answer when you do your cross products of 11x is equal to 13 times 9. And then you can solve for x. This one is a no-go because that's the bases of the triangle, not the sides. So when I'm talking about this triangle, when I go to write the proportions, I need to have it 8 compared to this whole side, which is 8 plus 3. And that has to be equal to comparing 10 is to x. So this is going to be the one that messes you up because you're going to say 8 is to 3. And that little piece only works when you're splitting the sides. All right, if you're looking here for number 4, A and B, go ahead and see if you can find the lengths of NR and GH. In the diagram in number 5, find QR. And here's the conversation about the triangle angle bisector theorem that I promised. So go ahead and work through the rest of this page with your partner and mark a set. Go. All right, let's see how you did. So if I come up to this triangle and I want to find the length of the distance from N to R, I'm going to go put an X on that. Now if I wanted to do it the long way, 9 to 9 plus x is equal to 6 to 10. That's fine. But if I want to use the side splitter, I can go ahead and say 9 to 6 is equal to x to 4. I know the side splitter applies because I have my sides split by those parallel lines. I know my triangles are similar because of this shared angle, and these parallel lines give me my corresponding angles. So when I'm solving for this, 6x is equal to 36, x is equal to 6, no problem. Now again, if you wrote 9 is to 9 plus x as 6 is to 6 plus 4, think about that property of proportions where we have our adding 1. So we can subtract 1 from each side and say 9 is to x. Or, yeah, a 6 is to 4. All right. When we talk about the length of GH, I don't necessarily have a triangle, but I can see that this is going to be 3 parallel lines divided by 2 transversals. So that means that those transversals are going to be divided proportionally. So 28 is to 30 as x is to 25. So 30x is equal to 28 times 25. If you grab your calculator and you go back to second quit, that takes you to your home screen. And I know that 28 times 25 divided by 30 gives me that fraction. And I heard somebody say math frac, enter. So 70 thirds. X is equal to 70 thirds. We're not using decimals, so make sure that your answers are either in simplified radicals or fractions, or whole values if that works. All right, so when we look at this next one, use the side lengths to find the length of QR. You're staring at this and you're like, what kind of problem is this? That's the triangle angle bisector theorem. If I'm finding QR, I'm going to go ahead and make that my x, and this becomes 18 minus x, because that angle bisector splits that third side proportional to the two sides of the triangle. So I can compare 12 is to x as 8 is to 18 minus x. So that means that 8x is equal to 12 times 18 minus x. So 8x is equal to 12 times 18 outside of my friendly numbers. See, that's 216 minus 12x. 12x. Add 12x to each side, so I get 20x is equal to 216. Boy, I'm writing one thing, saying something else. Isn't that funny? Is equal to 216. So then my x is going to be equal to, I go back to my calculator, 216 divided by 20 gives me this. Math, frac, enter, gives me 54 fifths. How'd you do? All right. If you were curious about the triangle angle bisector theorem, I love this diagram because it shows you why it works. So here's what I want you to do. Keep in mind, these are our angles that are bisected. And I want you to pretend that there's another line that's parallel to our angle bisector. So if I were to think about this line here, parallel to our angle bisector, I want you to think about this line here and this line being the same. I took it and I swung it up. So that line and that line, those two line segments I have marked are going to have the same length. Because the lines are parallel, I can look at this and now I can see these values being divided proportionally. So this is called an auxiliary parallel line that provides congruent corresponding angles, alternate interior angles, and isosceles triangle. So if I want to know how come these sides are all proportional, I get my way back to the side splitter theorem, where I have my A and my B and my C and my D. Keep in mind, those B's have the same value. So that gets you back to side splitter. All right. It's going to feel like a little bit of a heavier homework night, but that is because I don't see you because of the activity days. And I do want you doing practice. So you have this homework 5-6 and you have your Delta Math. I'm telling you right now, the kids that are doing the work, the kids that are paying attention in class, the kids that are doing the Delta Math are the kids that are learning, and they're the ones that are doing well. It's weird that I don't have you for class on Wednesday, Thursday, but you need to keep working because your review and your test are next week. So if you show up to class next Monday not having done any math for a week, it's going to show on your test grade. We're now at the part of the year where your formatives are becoming correctly proportional to your summatives. So the grades that have been skewed for the last 6 months are now coming into better focus. So it matters greatly how you're doing on the summative. If you haven't started your corrections, if you're not doing those ICTOBs or planning on a retake, that deadline is coming up. Next Thursday is the last chance that you have for your Unit 5A retake. If that's your goal, to improve that test grade, don't forget about it. Are we good? Okay. So in the time you have left, you could do a few problems.